Hi, my name is Stéphanie Baclay, and I'm a Senior Technical Marketing Engineer at Oxford Instrument Plasma Technology. Today, I will talk you through a short introduction on two of our products, which are the Atom Fab and the Ion Fab. I will discuss how these two products are addressing the cost reduction challenges for manufacturing optical combiners, which are used for augmented reality, and manufacturing of micro-LEDs, which can be used for display. So here you have an outline of this talk. I will start with an introduction on the company, so telling you a bit more about who we are and what is our core expertise. I will then review how the Atom Fab and the Ion Fab each address their target market. And I will conclude on a slide on how we work with customers, so how we can help you. So plasma technology is part of the material and characterization sector of Oxford Instruments. Our sector is composed of about 5 businesses. So we have Asylum in the US, makes AFMs. We've got Andors in Ireland. They develop and manufacture high-performance camera for confocal microscopy and spectroscopy. We've got Nanoscience in Tubney, just outside Oxford. They are the world leaders in creating samples environments for measurement and low temperature and high magnetic field. And then you have us, Plasma Technology. So we are located in Yatton, just outside Bristol, and we manufacture plasma etch and deposition equipment. So Oxford Instruments is doing well as a company financially. We have a revenue which is above 300 million. That revenue is spread globally. And in particular, the material and characterization sector account for about 43% of that revenue. We are about 1,500 employees, and a good 20% of us are R&D experts. So our core expertise is in building plasma reactor for material processing. This expertise is reflected in our product portfolio, where we focus on plasma-based technique. We have developed products based on more common technology, like plasma-enhanced chemical vapor deposition or reactive ion etching. We also have more advanced technique, like atomic layer deposition, atomic layer etching, and ion beam etching, ion beam deposition. And these two technologies are what I'm going to discuss in this talk today. So this know-how, we have applied it to a range of applications. Our customers are equally spread from R&D to production. And if we look at the application focusing on photonics, since this is a EPIC talk, we target a number of applications. So that includes 3D sensing, LiDAR, augmented reality, Internet of Things, datacom, and display. So as a company, Plasma Technology has many years of expertise in plasma processing. I think we've done a really good job at referencing all of our work. And as a result, we have a very comprehensive database of recipe across a range of material and a range of application. We have our knowledge center in the UK, so in Yatton, and there we have about 45 plus technical experts, and we are all looking at developing new products, improving existing technology, gathering information on what next development is required for our tool. So our lab is therefore well equipped. We have our own product, as well as characterization equipment like AFM, SEM, confocal microscopy, etc. In addition to our lab, we also have strategic partnership with multiple labs globally. We have partnership with ITRI, in Taiwan, with TU Eindhoven, where we do a lot of our ALD research, as well as with Berkeley in the US. So now let's get back to the title of my talk, which was about reducing cost. So with the micro-LED technology, a key target is to reduce the die size in order to allow more die per wafer and to reduce the wafer cost. Now, the issue is that when you reduce the size of the LED, its efficiency drops as a result of damages which occur during the front-end processing, particularly during the emitter edge step. So here you have some data from UCSB who are showing how the brightness of the LED drops at the low die size as a result of lower efficiency. What this work also showed was that with the appropriate passivation, here you see ALD and plasma etch, you could actually recover the damage on the surface and demonstrate high brightness. Now, this work was done on our FlexSol product. And for volume production with high productivity, our Atom Fab product delivers the same features than the FlexSol at higher throughput. So we have features like surface pretreatment, which are key to remove the native oxide after the emitter edge. And we also have an enhanced plasma source, which allow for low damage deposition with low ion energy, low ion flux, etc. And all of this at a cycle time which is 6 times shorter than any other conventional remote plasma source. So as an example here, I've put some data on our alumina film, which is very common for this application. And as you can see, we've demonstrated a high uniformity across 200 mil wafer size with good electrical properties. So if you read the table on the side, you'll see that we have a uniformity which is less than plus or minus 1%, and our breakdown voltage is around 7 megavolt per centimeter. So now augmented reality. So in this field, our product really target the fabrication of optical combiners based on surface relief grating, like glaze gratings, slanted gratings. And in this case, we are focusing on increasing yield to reduce cost. Manufacturing slanted grating in particular is an unusual process in manufacturing since it requires an etch with a negative profile. So to achieve such a profile, we use our ion beam patented technology. So for those who are not familiar with ion beam, we position our substrate at an angle in front of an ICP source, and we extract the ion from the source using a set of grids. And you can basically monitor or tailor the angle of your grating by setting the position of the substrate. So here you see an SEM of slanted grating etched in our reactor. And we offer a certain level of flexibility to manufacturers in this field because we recognize that it's a market which is still in development, not mature yet, and there's still a need for a range of design to be demonstrated before the final design can reach the customer, can reach the consumer market. So with our product, we can etch a range of slanted angles up to 55 degrees. We also have a built-in capability to do depth modulation so that you can increase the eye box. And we can etch a range of material, silicon dioxide, silicon, but also titanium dioxide. So now to conclude, how we can work with you. So depending on how mature your process is, we can work with you in several ways. We can support you in identifying the right material or technology for your application. We can specify the process recipe for a set material/technology combination. And we can also lock a best known method based on the yield optimization program. So it all depends on where you are in your process of defining your process. So we are very keen to do this for our target market, and that includes the two that I mentioned today, so augmented reality and micro LEDs. But we are also very active in a datacom market as well as a discrete market with devices like GaN and silicon carbide power devices. So please don't hesitate to reach out if you think we could collaborate together. So this concludes my talk. Thank you for your attention. You will find my email here on this slide in case you have any question, or if you would be interested in discussing about this application or learning more about our product. Thank you.